Hello, I hope you're having a great start to your day. These notes will help you work through your homework tonight and just continue with our logical progression for this unit. So for starters, this is on differential equations. I have exponential growth and decay, but that's not actually going to be covered in this video today. All right, so the first thing you need to know is the difference between direct proportion and inverse proportion. A direct proportion graph is one that is in the form of y equals k times x. The reason why we say they are in direct proportion with each other, we say y is in proportion with x, is because as x increases, y is also going to increase, and vice versa. So as x decreases, y decreases. K is called the constant of proportionality, and we will always use k to represent that constant that we are multiplying by x. Now, likewise, with inverse proportion, that's going to be y equals k divided by x. They are inversely related. X and y are inversely related. So again, if x increases, now y decreases. And if x decreases, then y is going to increase. And you can always plug in numbers there if you don't believe me, but I bet you guys get the hint. And again, k is called your constant of proportionality. Just one quick thing to note, another way to write this equation is x times y equals k. So when you multiply x times y, then you get a constant, which further helps to explain why as x increases, y decreases, and vice versa. Okay, so if you see something like the rate of change of y with respect to t, t being your variable like x, is inversely proportional to y. Okay, let's read that again. The rate of change of y with respect to t is inversely proportional to y. So we know rate of change of y with respect to t, that just means dy dt, rate of change of y with respect to t, derivative of y with respect to t, is equal to, well, let's see, inversely proportional to y. So it's inversely proportional, so k over y, okay? So when you read an equation or a description like that, that equation is going to be a representation of that verbal description. All right, this says write an equation where the rate of change of a population with respect to time is inversely proportional to the square of its population. Okay, so rate of change of population with respect to time is inversely proportional, so we know we're going to have k divided by something. And in this case, it says inversely proportional to the square of its population, so p squared. A lot of students want to say square root, but it would specifically say the square root of its population. So this is how we would correctly write that description. If it asked for directly proportional, then we would say dp dt is equal to k p squared, right? K times p squared. That would be direct proportional. All right, so hopefully that makes sense in how we would mathematically write these descriptions. All right, this one says, suppose the rate of change of a variable y with respect to t is proportional to the value of y. If it just says is proportional, we can assume that means is directly proportional to the value of y. Write a differential equation to represent this situation. Okay, the rate of change with a variable y with respect to t, so dy dt, is directly proportional. So k times to the value of y times y. Okay. B says find the general solution to this differential equation. Now, just a reminder, general solution means you're going to take your integral and have your plus c in the answer. So in this case, we have dy dt equals ky. And the way that we solve a differential equation, we may have talked about this a little bit on Monday. I'm not sure because I'm recording this before class, but that might be the case. But regardless, the way that we solve this, I'll pretend like you haven't heard this yet. We get y's dy's on one side and everything else on the other. So the way that I move that y over is that I'm going to multiply both sides by 1 over y, and I'm going to multiply both sides by dt, right? So this ends up being 1 over y dy is equal to k dt. Okay, well, this is just begging to be integrated, right? We've got this dy and dt. So let's integrate both sides of this equation. On the left side, we know the integral of 1 over y is the natural log of the absolute value of y. And the integral of k, with respect to t, is kt plus c, right? We're just using the power, the power rule there, right? The integral of 2 is 2x. The integral of k is kx or kt. All right, so the way that we get rid of that natural log on the left side, because what we're trying to do is get y by itself, we're going to raise both sides to the power of e. So on the left side, we're just left with y. And on the right side, we have e to the kt times e to the c. Now you might be wondering, why is this, there's two things you might be wondering actually. Where did the absolute value symbol go, right? From here to here, we lost our absolute value symbol. The reason why is because when we raise something to the power, or when we take e and we raise that to a power, that result is always going to be positive. So the absolute value bars are going to be redundant in that case. The second thing you might be wondering is, where did this e to the c come from? Well, this is just another way to write, if we do a little side note here, let me do this in a different color. Right? If you have e to the a plus b, that's equal to e to the a times e to the b, right? Same base, we just add the exponents. So now we're going in the opposite. Because we're adding exponents, we're now rewriting this as a product from this step to this step here. All right, so e to the kt plus c becomes e to the kt times e to the c. Well, what is e to the c? E to the c is e raised to some constant, which is just another constant. So we're going to call that new constant c sub 1. So we have y equals c sub 1 e to the kt. That right there is our general solution to this differential equation. All right, so continuing on, this says if t equals 0 and y equals 2, well, when y equals 2 and t equals 2 when y equals 4, find the specific solution to the differential equation. All right, so this is giving you two initial conditions to help you solve for c sub 1 and for k. Now notice, I should have said this also. E to the c became c sub 1 because these are two different constants, right? We can't just say e to the c is equal to c because, well, c's already been defined. So we just need to rewrite that as c sub 1 to show, hey, it's a new constant. All right, so anyway, I digress. This right here, when t equals 0, y equals 2, that's 0.0, comma 2. And this here tells us we have 0.2, comma 4. So using those two conditions, we're going to solve for c sub 1 and k. All right, so the first thing I'm going to do, I want to plug in the 1 with the 0 because that's going to get rid of that e term. So we get 2 equals c sub 1 e to the k times 0. Or 2 equals c sub 1 e to the 0th. Well, what's e to the 0th equal to? We know it's equal to 1. So therefore, we just determined that c sub 1 is equal to 2. Awesome. We can now plug that back into our equation, and we get y equals 2 e to the kt. Well, now all we have left to solve for is k. And we're going to use that second initial condition to solve for k. 4 equals 2e to the 2k. So I'm plugging in 2 and 4. So just so we can keep track of this, this is where I'm plugging in the 0, 2, and this is where I'm plugging in the 2, 2 and 4. All right, so now we're going to solve this equation. So divide both sides by 2. divide by 2, divide by 2. We get 2 equals e to the 2k. To get rid of that e, we're going to take the natural log of both sides. So natural log of 2 equals 2k, and then divide by 2. So k is equal to the natural log of 2 divided by 2. So the specific or the particular solution that we just found to this differential equation, given these two initial conditions, is equal to y equals 2e to the natural log of 2 over 2t. There is our answer. Okay? There's two more problems I want us to do before you try your homework. Again, we're solving these differential equations. In this first one, we're trying to get y dy on one side and x dx and anything else on the other side. So I'm going to multiply both sides by y and multiply both sides by dx. Right? So what we're left with is y dy equals x dx. Interesting. Okay, let's see what happens here. Let's take the integral of both sides. The left side becomes y squared divided by 2. The right side becomes x squared over 2 plus c. Now notice I didn't add c to the left side, like I didn't say c here, because I would just be subtracting this constant from this side, and this would be a different constant than the one on the right, right? And c minus c sub 1 is still going to give us a constant, so you don't need to write it twice. That would just be redundant. Just write it on the right side as you're integrating that x term. Okay, so now let's work to get y by itself. So let's multiply everything by 2. The left side becomes y squared equals x squared. Now, people want to say 2c, but remember, 2 times c is just another constant. So we're going to call that plus c sub 1. All right, so sure, 2c's is a thing, but it's better if you just write c sub 1. In fact, don't write 2c. Just turn that into a new constant. And then to solve this, we're going to take the square root of both sides, and you get y equals the positive or negative square root of x squared plus c sub 1. And you might be wondering, well, wait a second, is the answer positive or negative? It depends on your initial condition. If your output is positive in your initial condition, then you know that you're using the positive form of this answer. If your y is negative with your initial condition, then we know we're using the negative form of this square root. And when I say your initial condition, I'm talking about these that are given to you. So in this problem down here, you're not actually given an initial condition. So this would be your final answer. Y equals positive or negative square root of x squared plus c sub 1. All right, let's take a look at this last problem. And then you can work on your homework. This says x dy dx equals y. All right, so again, we want to get x dx on one side and y dy on the other. So let's see how we do this. I want to get dx out of the denominator, so I'm going to multiply both sides by dx. That gives me x dy equals y dx. Oof, but I need to get the x's with the dx's and the y's with the dy's. So we're going to multiply this right side, well, both sides, I should say, by 1 over y, and both sides by 1 over x. Times 1 over x. All right, and on the left side, we are left with 1 over y dy, and on the right side, we're left with 1 over x dx. And again, we now have y's, dy's on one side, x dx's on the other side, so let's integrate. The left side integrates to the natural log of the absolute value of y. The right side integrates to the natural log of the absolute value of x plus c. Okay, let's see. How can we figure this out? Well, we could subtract natural log of the absolute value of x from both sides, and we get natural log of the absolute value of y minus natural log of the absolute value of x equals c. Using our log rules, we know this is the natural log of the absolute value of y over x equals c. If you raise e to both sides, you get y over x equals e to the c. Okay. And now, if we multiply both sides by x, we get y equals e to the c times x. And again, we know that e to the c is simply c sub 1. It's another constant, c sub 1 times x. Okay, so that's one way that you could do it. But let's say that you didn't notice that, and instead, let me see, I need to make some room here. Let's go back up to this step here, okay? And let's come down here. Let's say instead you were like, you know what, I'm just going to raise both sides to the power of e. All right, that would look like e, here we go, e to the natural log of the absolute value of y equals e to the natural log of the absolute value of x plus c. And again, we know that e to any power is going to be positive, so we can actually get rid of that x, or that absolute value. All right, so this becomes y, stay consistent with my colors. This becomes y equals e to the natural log of x times e to the c, for that same reason I explained above. That this can be simplified into a product using our exponent rules. All right, so e to the natural log of x, well, we know that that's just equal to x, and e to the c is another constant. Oh my gosh! Look at what we end up with. The same exact thing that we ended up using the other technique. All right, so either way, we end up with the solution y equals c sub 1 times x, which is the answer to this problem. Okay, so go ahead and work through those practice problems for your homework. I posted the solutions online. Use those as a guide to check your work, but don't use them to actually do your work, right? I mean, we want to make sure that we're getting this practice and being intentional about the practice that we do. So I should mention in the homework when it says y prime, that just means dy dx, but I'm sure you already know that. All right, so good luck with that, and we will talk about this on Thursday or Friday, depending on what period you're in, when I return. Thank you for your hard work, and I'll see you guys at the end of the week.